The blockchain for dummies. Cryptocurrencies and blockchains are the subject of increasing interest from the general public, but this universe does not shine by its simplicity of access. While the technical understanding of these technologies requires a long learning process, it is nevertheless possible to grasp the basic concepts that govern their operation. This video is intended to be an introduction to the subject for accessibility to as many people as possible, and therefore does not claim to be exhaustive. The concept of blockchain dates back to 2008. It appears with the cryptocurrency or digital currency, Bitcoin, which uses technology. The development of the latter is attributed to the unknown person presenting himself under the pseudonym of Satoshi Nakamoto. But if blockchain and Bitcoin were built together, today many players, companies, governments, and such are considering the use of blockchain technology for their cases other than digital currency, for example, in an international trade. There are many definitions of the blockchain. More or less complex or technical, it must be admitted that like everything that is virtual and therefore abstract, it is not easy to define the concept. The dictionary has tried to compile different definitions to arrive at a clear and relatively simple approach, but without making the term meaningless. Before we get into it, let us know what you think blockchain is in the comments below at the like button, sub button, bell button. Let's start. Blockchain is a technology for storing and transmitting information, transparent, secure, and operating without a central control body. By extension, a blockchain is a database that contains the history of all exchanges between its users since its creation. This database is secure and distributed. That is, it is shared by its various users without an intermediary, which allows everyone to check the validity of the string. With this first approach, we can already identify an essential aspect of the blockchain. Its great peculiarity is decentralized architecture. That is to say that it is not hosted by a single server, but by some of the users. There is no intermediary so that everyone can verify the validity of the chain themselves. The information contained in the blocks, transactions, title, contracts is protected by the cryptographic procedures which prevent users from modifying them via posterior. So, an important thing in the concept, the solution works without a central control body. Each user can at any time, using cryptographic system, verify the validity of the information in data and record in transaction. Let's sum up. Oversimplifying what is reasonable, the blockchain is a huge database which is transparent because of the members who compose it and console all of the exchanges from the origin to the present without a supervisory body, a trusted third party since its founding principle is peer-to-peer exchange, tamper-proof because all elements exchanges are distributed. That is, there are a large number of copies simultaneously on different computers known as nodes in the network. To modify something, it would be necessary to do it simultaneously on all these nodes. Mission impossible. As the mathematical Jean-Paul Delahaye writes, imagine a very large notebook which everyone can read freely or for free, on which everyone can write, but which is impossible to erase and indestructible. But still, when it comes to data, it can be anything. But the most interesting uses are for information that usually requires a trusted third party to be exchanged. For example, currency requires a bank, a deed of property requires a notary, and loan certificate and so on. In essence, the blockchain makes the presence of a third party unnecessary. We can already imagine why some observers say that this technology can upset many industries as much as the internet when it first appeared. A little practice: when a user performs a transaction through the blockchain network, the transaction is grouped together with other related transactions within a block. It is then verified and validated by the members of the network using cryptographic techniques. This step, called mining, makes it possible to verify its authenticity to ensure that the structure is correct and that it's consistent with previous ones already recorded. Once validated, the block is immediately time-stamped and added to the blockchain. The operation becomes visible and accessible to all users, but can no longer be modified even in the event of error. When such a situation occurs, the rectification only requires the addition of a new transaction. The validation of a transaction is almost instantaneous. However, it varies depending on the size of the operation performed. The time required for such confirmation is usually in the order of 10 minutes. To create a new block, there are different methods, the best known being proof of work. Miners have to compete with each other in computing power to solve a mathematical problem. The successful miner or group of miners gains the opportunity to create the next block of transactions. The network of great computing power helps secure transactions. The The incentive behind mining is the reward. These are the transaction fees as well as the new units of cryptocurrency accessed with blockchains. A public blockchain operates on a distributed consensus model among all network participants. To ensure the validity of a new block transaction, all nodes of the network will verify that the block complies with the rules of the protocol. Blockchain technology is interesting in more ways than one. In the context of cryptocurrencies, it allows in particular to solve a problem of double spending, which consists of spending more than once the same digital token. However, there's still a risk of 51% attack, which involves having more than 50% of the network to impose a new block. The risk is theoretical because blockchains like Bitcoin or Ethereum have networks that are far too large and to be able to own the majority of the nodes. Blockchain is a so-called trustless technology because it does not require a trusted third party to carry out transactions. In truth, trust is not completely eliminated from the process, but instead of being based on an individual or group of individuals, such as institutions, trust is here based on the code and its rules. Private keys. Cryptocurrencies are based in asymmetric cryptography encryption. Crypto asset holders use their private key to sign transactions and prove that they actually own funds they want to spend. Some rules must be absolutely respected in the management of private keys. Always save them. There are a series of characters, so it can be done on a piece of paper kept in a safe place, and never erase or destroy them, even if no crypto asset is associated with it. Originally, there is Bitcoin. The most famous cryptocurrency was created on January 3rd, 2009 by Satoshi Nakamoto. It is crucial to understand that Bitcoin is the geniusness of cryptocurrencies, and therefore it is from Bitcoin that all other cryptocurrencies, altcoin, originate, including Ethereum. These cryptocurrencies try to improve certain aspects of the Bitcoin blockchain, such as the speed of the transactions, but the very foundation of this altcoin is modeled on Bitcoin, which is not the first cryptocurrency stricto sensu, but which is the first to have managed to avoid the pitfalls of the previous ones faced, in particular the problem of double spending. Among the ancestors of Bitcoin, we can cite DigiCash or CypherCash. What Bitcoin has brought, Bitcoin also relies on the pre-existing technologies, such as decentralized databases, asymptomatic cryptography, hash functions, or even blockchain. But the first real cryptocurrency also brought major innovations. In particular, it enabled the creation of an intrinsically digital economic space. It is also advent of a triple entry accounting, entry-exit immutable public ledger. According to the supporters of cryptocurrency, they offer the possibility of evading the monetary policies carried out by central banks, since the rules for issuing crypto assets are defined in the blockchain protocol cannot be changed without the consensus of the network. Some of the non-financial blockchain applications, blockchain technology is intimately linked to cryptocurrencies or tokenization, but its applications are not limited to the exchange of value. Although for wide applications to be possible, there must always be an exchange of value. A crypto asset transaction can be accompanied by a message or a digital fingerprint. When launching Bitcoin, Satoshi Nakamoto incorporated the title in an article of the Times that appeared the same day, Chancellor on the brink of a second bailout for banks. This press article made it possible to timestamp the first transaction and therefore prove the date of the launch of Bitcoin network. Likewise, it is possible to attach a digital hash to uniquely identify information. The code does not allow access to information but verifies its integrity and authenticity. Anyone in possession of the original information can produce a digital fingerprint and verify that it matches one record on the blockchain. The mechanism is particularly useful for the works of art or innovations that require proof of date of creation. It also makes it possible to carry out notarization or maintain official public registers by guaranteeing the immutability of the data stored on the blockchain. Another derivative of blockchain is tokenization. Previously, uploading a document over the internet involved creating a copy of that document. Thanks to the blockchain, it is possible to transfer digital objects. This is the case with the works of art that are subject to the growing media industries. These works are associated with an NFT, non-fungible token for non-fungible token. The token holder can thus demonstrate that he is the owner of the corresponding work. Smart contracts. The most advanced blockchain applications rely on running decentralized software or applications. These are smart contracts. The more advanced programming language used, the more sophisticated smart contracts. The Ethereum blockchain has the most applications. The purpose of smart contracts are to verify the certain conditions that are met, determining whether a user has a right to carry out the transaction. Smart contract technology is still in its infancy, but many applications already exist. In the insurance sector, it's noticeably possible to create smart contracts that can automatically compensate a client if certain conditions have occurred. The activation of a smart contract requires the conditions to be listed on the blockchain by a third party. Smart contracts are also used today to reward artists through crypto, copyright, and based on individual contribution. If a smart contract literally means intelligent contract, it should never be borne in the mind that these software are not intelligent. They perform in the functions which have been assigned to them, depending on information transferred to them. To verify that execution conditions are met, critical smart contract observers see it as information asymmetry, as not as possible for the contract recipient to observe the signal sent by the sender. As smart contracts are deemed to be immutable, they cannot be changed. Not turning back is possible, and no recourse is possible. This wraps up today's video. I hope it helped enrich your knowledge. Let me know your opinion in the comments below. Thank you guys for watching. If you enjoyed the video, hit the like button, sub button, bell button, and have a great day. Take care of your pockets and loved ones, and I'll see you in the next one.